Okay, guys, let's see if we can finish up section 8.1 here. So we'll call it part B. Uh, I think if I do A and B, those are joined together like as one homework assignment. So section 8.1 only has one homework assignment, so we're just going to finish up the notes. A few more examples. So where were we at? So this is section 8.1 part B. What were we doing? Determine whether the sequence converges or diverges. If it converges, find the limit. Okay, so this guy here, same thing as the other ones. We could do divide everything by the highest exponent, or we could do L'Hopital's rule. I think whatever you want is okay. I think the higher this gets, the more times that you have to take the derivative, right? But if you can take the derivative quickly, then you might want to just do that. Otherwise, we're going to do the limit. Either way, we're going to do the limit as n approaches infinity of n to the fourth over 5n to the fourth plus 1. Okay, so I'm going to do the division. If you want to try L'Hopital's rule and see if you do it just as quick, then you can do that route. Notice I take the highest exponent in the denominator. I don't care about the numerator, I do it in the denominator. So the limit as n approaches infinity, I'm going to do n to the fourth divided by n to the fourth. I'm going to do 5n to the fourth divided by n to the fourth, and 1 over n to the fourth. Okay, and then we're going to simplify. So this goes to 1. This cancels, so that goes to 5. And then this guy has to stay. Okay, but I'm doing the limit as n approaches infinity. So what happens as I get bigger and bigger and bigger on the bottom here, on this small fraction right here, this fraction is headed towards 0. So I have 1 over 5 plus 0, so 1/5. So it does converges, and it converges to 1/5. Okay. Remember here I said I was going to do it again to see the sequence. Okay, not that you have to, but you would plug in a 1, and so you'd get 1/6. You would plug in a 2, so I get 16 over 81. You plug in a 3, it starts to get kind of big right away. 181 over 406, ... Okay, so that's our sequence. We could keep going, but just remember this is the rule. If you want to actually see the sequence, you just plug the numbers in. Okay, all right, let's try something a little bit different. Let's try this guy. Same directions though. Let's just take a look at the problem. A to the n equals 3, and the exponent is n plus 2, and then divided by 5 to the n. Okay, cannot see that. Okay, good thing I looked up. That's a problem. It's like an overhead for you old people. Right, the teacher would write and you couldn't see anything. Okay. All right, so this is just going to take a little bit of rearranging. Okay, when we add exponents, that really means we were multiplying. So we're going to write this as 3n times 3 squared. Now normally when we had this, we would write it as 3 to the n plus 2. So we're going to break it up, and we still have 5 to the n. Okay, and we're going to take the limit. So we want the limit as n approaches infinity. Okay. All right, so now we want the limit as n approaches infinity, and we're going to rewrite this a little bit differently. I'm going to write this first, 3 squared, and then I'm going to do, because this is all multiplication and division, I can kind of break it up, 3 to the n over 5 to the n. Okay. And then this we can even rewrite, the limit as n approaches infinity. We could even change that 3 squared, we could change that to 9, that's just a constant. And then this can be written as 3/5 to the n power. As long as you can't bring this exponent in if you're adding or subtracting, but if you're multiplying or dividing, you can definitely bring that in. So you can bring in the exponent, and it would be written just like this. Now, we haven't done this one for a while. What is this guy? This is r to the n. And my r is 3/5. So it falls between this guy. I don't want to move my hand, right, because then it messes everything up. Okay, so can we see? So my r falls right between that guy. So, and we can even do this. I'm going to do the limit as n approaches infinity of 9, and then times, that's this guy right here, the limit as n approaches infinity. Remember, that's why we wrote all those laws of limits. We can split everything up, right? So as long as my r falls between these guys, my limit is 0. So the limit of 9 is 9. The limit here of r to the n, remember I'm doing r to the n, because the r falls in between here is 0. So it does exist. It does converge to 0. It converges. And that's okay, and the limit is 0. That's okay to have an answer of 0. Good. All right, so that one was a little bit different. All right, let's try another one. A to the n equals the square root of n plus 1 over 9n plus 1. Okay. All right, so we're going to, since we have the rule, we're going to take the limit as n approaches infinity of this guy. But what am I going to actually do here? You can just even think about it, but I'm going to actually do the square root last, and I'm going to worry about just the limit as n approaches infinity of n plus 1 over 9n plus 1. Okay. And I would actually get infinity over infinity. So let's do L'Hopital's rule. Or you could divide everything by n to the first. Either way you want to look at it. If I take the derivative here is 1, and the derivative here is 9. Okay. So now, because I would get infinity over infinity, it's okay to do L'Hopital's rule. So now I'm doing the limit as n approaches infinity of 1/9. But it's a constant, so the limit is automatically 1/9, and it's okay to wait and then take the square root. Remember, the laws of limits lets us break everything apart, do anything in any order we like, which is so nice. So it does converge, and the limit is 1/3. Converges. Okay. All right, let's try another one. I think we can even fit it on here. Should I slide it up? Is that okay? All right. I don't know why, because you can, as long as you can see the bottom, then that way if you need that a little bit longer. All right, so a sub n equals cosine of n over 2. So we have the rule, so we're going to do the limit as n approaches infinity of cosine of n over 2. Same thing though, remember limits, we can do stuff in any order that we like. So I'm going to worry about the cosine later, and I'm going to do the limit as n approaches infinity of n over 2. Okay. If I have a fraction, I'm really just supposed to divide by the highest exponent on n in the denominator, which I don't have an n at all. So I kind of just have to look at this. I'm kind of done. What happens to a fraction as the top gets bigger and bigger? As the top gets bigger and bigger, the number, the overall value, even though technically I'm dividing by 2, it's always going to slowly get bigger. So this diverges. So taking a cosine of a bigger and bigger number, it's going to diverge. This diverges. Okay. So sometimes we kind of have some, right? You really got to play around with it. You got to rearrange things. You've got L'Hopital's rule. You've got divide by that highest exponent, but sometimes you just have to look at it. Okay, and that's kind of the hard part. It's all over the place. All right, let's try, let's see. We got 3 more. Okay, 4 more. All right, so let's look at a sub n equals cosine of 2 divided by n. Okay. So if I have the rule, I'm going to take the limit. I want to know what happens as n gets bigger and bigger. Cosine of 2 over n. Okay. I'm going to take, remember the nice thing about limits, you can do any order you like. So let's not worry about cosine right now. Let's worry about the limit as n approaches infinity of just 2 over n. And then we'll worry about the cosine. Okay. All right, so this is one where we're just going to look at it, right? What happens as we have literally one little fraction. What happens when the the denominator gets bigger and bigger and bigger? 2 divided by 1,000, 2 divided by 1,000,000, that is heading towards 0. So we've got cosine. We still have to do cosine, guys, but this is headed towards 0. So cosine of 0, cosine of 0, this is headed towards 0, but I still have to do cosine. What is cosine of 0? Cosine of 0 is the x-coordinate, so it is 1. So the overall limit, crazy noise. Okay, sorry, I don't know if you heard that, but a little scary. It's a little windy out today. The overall limit is 1, so it does converge. It converges, and it converges to 1, not 0. This limit is 0, but I still have to take cosine of 0. Good. Okay, this one's a little bit harder. Let's get, I don't think it's that long, but let's take a look. A sub n equals n squared times e to the negative 3n. Sometimes, I know my hand sometimes gets in the way, so that's my fault. Okay, so we're going to do the limit. We've got the rule, so we're going to do the limit as n approaches infinity of n squared e to the negative 3n. Okay. Now, any ideas here? What we're going to do here is we're going to make this positive. So we're going to make it a fraction. I know we don't love always fractions, but we're going to make it a fraction. We're going to move this to the bottom, and then we're going to have e to the 3n. Okay. So it's not our traditional. I don't think we can like divide anything, but when we have something like this, when I'm taking the limit, if I plug in, 1,000, 1,000,000, and squared, if I plug in if I plug in 1,000, it would actually be 3,000. I would get infinity over infinity if I plug in bigger and bigger numbers. If the limit is infinity over infinity, L'Hopital's rule. So this time we're kind of forced to use his. Let's use L'Hopital's rule, which says take the derivative of the top, take the derivative of the bottom. So the limit as n approaches infinity, I'm going to take the derivative of the top, roll it down, subtract 1. What's the derivative of e to the 3n? The derivative of e to the 3n is e to the 3n, but then I have to take the derivative of this guy, so I'm just going to put it here, the 3. Okay. But did that really help? Because I still am going to have infinity over infinity. As I plug in bigger numbers, the top's going to get bigger. As I plug in bigger numbers on the bottom's going to get bigger. So I've got infinity over infinity. So we do it again. Remember, when you use his, chances are you're going to do his a couple times. So this goes to 2. This, the derivative of e to the u is e to the u, but you have to take, and the 3's there, but then you have to take it times the derivative again, so times another 3. This 3 just stays. And then I'm taking the derivative of e to the u. Derivative of e to the u is e to the u, but then I have to take the derivative of that quantity. All right, so we got the limit as n approaches infinity of 2 over 9 e to the 3n. Okay, I no longer have infinity over infinity, so I'm done with L'Hopital's rule because the top is always going to be 2. The top is not headed to infinity. But what is happening to the bottom? I mean, if I said it was happening here, and I said it was happening here, and now I'm taking it even times 9, the bottom is still headed to infinity. Okay, so what happens to a fraction when the bottom heads to infinity? So my top is now stabilized at 2, but the bottom is getting bigger and bigger and bigger. It's headed towards 0. Okay, so it does converge. Converges, and it converges to 0. This is getting bigger and bigger. Just the bottom. If the bottom gets bigger, it's headed towards 0. Okay. All right, we got 2 more. How are we doing at time? Beautiful. Okay. Let's try this guy. A sub n equals now the natural log, can you guys see, of 2n squared plus 1 minus the natural log of n squared plus 1. Okay, that looks kind of crazy. If I move my hand, then it goes in and out. Okay, so I'm going to try to keep my hand there. All right. Any ideas here, guys? Remember, 2 logs of subtraction is 1 log of division. Okay, and since it's a rule, I'm going to take the limit. So I'm going to try to do 2 steps in one here. I'm going to take the limit as n approaches infinity, and then it's going to be the natural log, 2 logs of subtraction, 1 log of division. Okay. Okay, and then limits, because I'm taking the limit, I can do any order, so I'm going to worry about the natural log later, and I'm going to do, oops, I didn't want to write that. I'm going to print the limit just so that we can follow it. The limit as n approaches infinity. So I'm going to take the natural log and do that later, and I'm just going to focus on this, which we've seen before, right? This is one where we can take we can do L'Hopital's rule, or we can divide everything by the highest exponent in the denominator. We can divide everything by n squared. So I think I'm going to do that. 2n squared divided by n squared plus 1 over n squared, and then n squared over n squared plus 1 over n squared. If you want to just do derivative, that's okay too. All right, so this cancels. So I get 2 plus 1 over n squared. This cancels, so I have 1 plus 1 over n squared. Okay. But don't forget, I'm still taking the limit as n approaches infinity. So what happens, that looks messy, okay. What happens as this fraction gets bigger and bigger and bigger, it's headed towards 0. Same thing down here, this guy's headed towards 0. So that gives me the limit then. I really have the limit as n approaches infinity. Oh dear. Can you, I don't know, maybe you guys can't even tell. The lights just went out. I'm sitting still. Okay, oh dear. Okay. Actually, maybe it's better with the lights out. I don't know. All right, so this then is 2. So the limit, because it's a constant, it's 2. And don't forget, we took it out of order, which is fine for limits, but I just have to remember ln. So actually, it does converges, and the limit is actually the natural log of 2. Okay. All right, and then the last one, I think we've done this before, but for some reason they put it at the last problem, so let's just do one more. Remember, if it goes 0, 4, 0, 4, 0, 4, and like I said, I think we've done something like this. But the very last problem, I think it's the very last problem, they're not going to give you a rule, and that's okay too. If they don't give you a rule, then you kind of have to do it. You can either create a rule or just look at it. It's changing between 2 numbers, but we want it to approach 1 number. If it's not approaching 1 number, then it diverges. All right, so you guys are good. Okay, so you want to try section 8.1's homework.